So inverse functions undo each other. That is the purpose of them. Like I did one thing, now I want to undo it. So they undo each other. The words inverse, reciprocal, and opposite get thrown around a lot, those three words, as though they are interchangeable. They're not, okay? An inverse function, two inverse functions undo each other. So the way that you get one is you switch X and Y. You are reversing the input and the output. Do you ever like see one of those number games where like pick a number, any number, add 2, divide by 3, multiply by 7, and then it comes back to your same number in the beginning, or they force it to come out to 3 or something? They're using an inverse function to do that. They're doing a bunch of operations and like hiding it in there and then undoing them to take it back to what they want it to be, is what they're doing. So if you switch the input and the output, your domain and range are reversed. So if you get asked for the domain and range, which you will, they're just reversed. So the domain of one is the range of the other, vice versa. Now, if you want to check if two functions are inverses, you're going to check, do they undo each other? So you'll do f of g and you'll do g of f. And if they both come out to just plain x, then they are inverses. If they come out to anything else in the world, then they are not. So if it comes out to x plus 5 or 7x or x minus 2, or if they undo each other perfectly, it will come out to just x. No, and there should be a variable. So you shouldn't get just a number. And then lastly, if you're going to graph them, which you can see we have some grids here, they reflect over the line y equals x. I wrote too big, so that kind of got squished in there. I'm sorry. They reflect over the line y equals x. Let's just talk real quick about what the line y equals x looks like, just to make sure that we're all on the same page. You don't have to write this. I'm just going to grab a little sticky note. If I go to graph y equals x, it's going to start at the origin. And what would the slope be if it's just x? 1. Like you would go up 1 over 1. Do you see what I'm saying? It would look like this. This is your line y equals x. We all together? Well, I don't like to make assumptions because sometimes then I go to the graph and everyone's like, what on earth is y equals x? That's what it looks like. Right? So are these inverses, yes or no? Here's what you're going to do. You're going to find f of g and you're going to find g of f. And yes, you have to label them because I need to know which one is which. And you're just going to see what they come out to. The thing is, people try to force it. They try to make it come out to us. So they get like a preconceived notion and make it come out to something. Don't do that. You're just testing. You're just going to see what happens, right? So for this one, g gets plugged into f. So this 3x minus 2 gets plugged in right there. It's going to look like this. I just removed the x and replaced it with 3x minus 2. And we're going to work our algebra magic and just see what we get. So what would you do with the 1/3? Yeah, you would distribute. Now, 1/3 times 3 cancels. You get just 1x. So that's good. Minus 2/3. 1/3 times 2 is 2/3. Now it's plus 2, but I need a common denominator. So the $1 million question is, how many thirds is 2? And it is 6. 6/3 is 2. So when you put those together, it'll be x plus 4/3. Where did I get 4 from? Yeah, -2 plus 6. So we already know that the answer to this question is no, because that did not come out to just x. And so here's what the kickback I always get every year. Why do I have to do the second one? Because on a quiz or test, I make it worth points to do all the steps. It's worth something. So you have to do it. Do you understand what I'm saying? Because I can't tell you ahead of time whether the answer is yes or no. So you have to do both of them. Just go, oh, I'm getting credit for this. If you plug f into g, this whole thing now gets plugged in over here. So you're going to remove the x and replace it with 1/3 x plus 2. You okay? Okay. And then you're going to work your algebra magic and just see what it comes out to. So what would we do with this 3 out front here? Yeah, distribute. And so again, 3 times 1/3 cancels. You would get x plus what? 6, then minus 2. And that one's a little bit easier because you don't have a fraction. Bless you. And so it comes out to x plus 4. And so again, we already knew the answer was no because they didn't just come out to x. For the sake of time, I'm going to not do this one. You would do the same thing. You would do f of g, you would do g of f, and just see what they come out to. Are we okay there? And the point of notes is for you to just understand what's going on, and I want you to have time to do your classwork. So if you understand it, I'm not going to do the one that's exactly like it, okay? Find the inverse. What you're going to do is switch x and y. Switch x and y. So what I always say is it would sure help a lot if there was a y in the problem. So the f of x means y. So I usually just tell everybody, scribble that out and call it y. And here's the thing. You switch x and y, everything else stays put. The equal sign is going to stay where it is. The 3 is going to stay where it is. The -2 is going to stay where it is. Don't change any of that. You're just swapping the input and the output. So it's going to be x equals 3y minus 2. And then you work your algebra magic. What would you do to both sides? Add 2, good. And then divide by 3, good. So it's going to look like this. Now, if you write equals y, full credit, because for heaven's sake, it's the right answer. But does anyone remember what inverse notation looks like? Because I'll be happier in my heart if instead of y, you put the inverse notation.
It was f of -1.
With a little -1. That just means inverse. That is just notation that means inverse. Okay.
But you would.
I would not mark it wrong if it's the right answer, but I'll be happier in my heart if you put this because it means you're showing me you know what the notation is. Okay.
She did mark mine wrong.
All right. I'm going to cover all this up. We're going to go back to the original problem. This is in your good old y equals mx plus b. Welcome back to Algebra 1. How would you graph that? Literally doing this with my Algebra 1 students right now. So you would go down 2. Good. And then your slope is 3. So you would go up 3 over 1. Up 3 over 1. You can count to 3. You can do it. That's what I always tell them. That's my pep talk. We started at -2. Right there.
Oh, we're graphing that one.
Yep. Well, we're going to graph that one too. I covered all this up. Yeah, well, they don't match. Hold on a second. You're right. Just let me get everybody there. Now, when you go to graph the other one, I probably wouldn't look at this. That's confusing. So don't look at it. In fact, you can get the graph correct even if this is wrong. All right, just don't even look at it. All you're going to do is reverse the points. So this point is what? 3, 6. So instead, I'm going to plot 6, 3. You don't negate them, you just reverse it. So instead of 3, 6, I plotted 6, 3. This one is 2, 4. So instead, I'm going to plot 4, 2. Oh, is it a 7? I'm sorry, I can't count. Hold on. 1, 2, 3, 4, 5, 6. Yes, thank you.
So 2, 4.
7. Okay, so I'm sorry. 7, 3. I apologize. I was going to catch it in a minute because the slope wasn't going to work out. All right, 1, 1 would still be 1, 1. And then do you see what this slope is going to end up being? Instead of 3, it's 1/3. Do y'all see that there? And doesn't that make sense? Instead of 3, it's 1/3. And then here's the other way you can check your work. You do not need to dot this in. I will not mark it wrong. Actually, I'll use my gold marker here. But if you dot in y equals x, do you see how they are a reflection? You don't have to dot that in. It's not part of the problem. I'm just illustrating it for you. It's another way you can visually check your work. That's all. All right, let's try another one.
These look so cool.
I like them. I like inverses. I think that this is, there are certain topics I like teaching better than others. I like this one because it usually goes well.
I have a question.
Yeah, go ahead.
So what's the point of finding this right here? The x plus 2 over 3.
That's you showing me that you can do those algebra steps. That's basically because the standard said so question. I'm sorry. I know that's a really crap answer, but that's because we said so. All right, so scribble out f of x. We're going to call it y. Everything else stays put. You just switch the x and the y. So it'll be x equals y cubed minus 4. And you got 2 steps of work. You're going to add 4. And then who knows how to get rid of a cube? Cube root. So it's going to look like this. And again, if you write y, fine. I am not going to mark it wrong because for heaven's sake, if you get the right answer, I'm thrilled. But I will be happier if you put inverse notation because that's you showing me that you know what that notation is. But again, you can get the graph even if that's wrong. I wouldn't even look at it. Let's graph this. What shape is it going to be?
The squiggly.
A squiggly. And it moved down 4. So you're going to go down 4. And then let's try and get a few more points. If you can do it in your head, that's cool. If you want to make a little table, that's cool too. We have a point at 0. Can you give me some numbers next to 0? Yeah, like 1 and... Yeah, we already did 0. And I would do 1 and -1. So if you plug in 1, this should be quick and easy. 1 cubed, 1 minus 4, -3. And -1 cubed is -1 minus 4, -5. So it's actually going to look like a straight line. You just need to know that it wiggles. And you can plug in 2 as well if you want and get more points, but 3 is good enough for me. If you have 3, I'm happy. And again, all you're going to do is take those points and reverse them. So what is this one? -1, -5. If you reverse that, -5, -1. And that's why writing the table is kind of helpful because you can see it. You can just take these and, flip them the other way. Instead of 0, -4, -4, 0. And instead of 1, -3, you have -3, 1. Now, again, it looks like a straight line, but it's the wiggly thing on its side. Usually I just turn my paper. It's going to look like this. And again, you don't have to dot in y equals x. It's not a requirement, but it helps you just like see, oh, I've got the right answer. Like it's just a visual way to check it. Now, we don't need to maybe do every single one of these on the back. We just need to do enough so that you know what's going on. We're not going to graph them. We're just going to find the inverses. All right. So scribble out f of x, call it y. Let's switch x and y. Everything else stays in the same place, though. Don't move the fraction bar. Don't move the 2. Don't move the 1. Now, this one's a little tricky on the algebra because there's a fraction. You have to get this y out of the denominator. So I would take this y minus 1, multiply it to the other side. So it's going to look like this. Algebra is just moving stuff. I literally just moved this over here, is what I did. And then we're going to divide both sides by x. Good. And then add the 1 over. So I kind of ran out of space. You're just going to add this 1 to the other side. And again, I'll be happier if you put inverse notation. It'll look like this. I always write too big. All right, let's do number 6, and then maybe we'll do 8. Looks like a scarier one. You can go ahead. Or do you have a question? Go ahead. Yeah. You switch x and y, and then you solve for y. No, we solved for y. We got y by itself. You solve for y. You switch x and y, and then you solve for y. All right, so this one, scribble out f of x, call it y. We're going to switch x and y. You're super quick. You're saying it faster than a lot of people can write it. But yes, your first step would be to multiply over the 5. So you'll have 5x equals that stuff. All right, then what? Cube root. Good. Well said. And then subtract 2. I'll skip 7. But do you see how that has a 5th root in it? What does that mean would have to be in your inverse? If this has a 5th root, something to the 5th power. Do you get what I'm saying? Like it would have to have something to the 5th power in it. This one has a 7th root, so our answer is going to eventually have what in it? Yeah, like something to the 7th power. So you're going to just recopy the whole thing, but swap x and y. Everything else stays put. The 7th root stays where it is. The 2 stays where it is. The fraction bar stays where it is. I just swapped the x and the y. Now I picked 8 for us to do because it has more steps. There are 4 steps of work. And it's just getting them in the right order. What would you do first? Yeah, move the 6 over. This is called unwinding what you're doing. You're unwinding what's there. That's what you guys are doing. All right, then what? Go to the 7th power. That'll get rid of the 7th root. You're just trying to undo everything that's there. So now we divide by 2. I'm not going to rewrite that. It's fine. I can't do anything to this anyway. So. And then what's your last step? Yep, add 9. You do a lot of recopying because it's all of that same stuff and then plus 9.